So, hopefully if you've seen multiplication in trigonometric form, you remember trigonometric form is a way of describing a complex number in terms of the angle rotated counterclockwise from the positive x-axis and the distance from the origin. Okay? Now, the way that you describe this, of course, the real part, the distance out here, is r cosine theta, and the imaginary part is going to be r sine theta, so we write r times cosine theta plus I sine theta. That's trig form, or the shorthand is r cis theta. Since we always have cosine I sine, you just write theta once. Okay, so the rule for trig multiplication is r cis theta times s cis psi equals r times s cis theta plus psi. Okay? That's a pretty easy rule. You multiply magnitudes, you add the angles. But that's just weird. I mean, maybe somebody could show you a few examples, but why on earth is that actually true? Well, we're actually going to have to go back to what these are, go back to the definition, and give a proof of why that actually works out the way that it does. Okay? So, looking at the left-hand side of this, we're going to start at the left-hand side and hopefully work our way to the right-hand side. So if I've got r cosine theta plus I sine theta times s cosine psi plus I sine psi. Okay? Well, hopefully you can see that since everything is commutative here, that s comes through. So we have r times s. That's probably not so surprising. You multiply and the magnitudes get multiplied. But then you have this piece times that piece. Okay? Now what you're going to have to do is you're going to have to distribute. So that cosine theta is going to be times both of these pieces. So let's see, what do I get? I get cosine theta cosine psi plus I cosine theta sine psi. Okay, now I'm going to go down to the next line, but it's still part of the same equation. This has to distribute to both of those things. So what do I get? I get I sine theta sine psi plus I squared sine theta sine psi. Okay? So that's what it's equal to. Now let's see if we can't simplify that a little bit. So that whole mess, we have r times s, right? All times, what happens with this I squared? That's a negative. So what's the real part of this? The real part of that is cosine theta cosine psi minus sine theta sine psi. Now, hopefully that rings a bell. Cosine, cosine minus sine, sine. That's actually the sum of angles identity for cosines. So what we have there, that's just, in fact, maybe I'll just write it right now. That's the identity for cosine theta plus psi. Okay? And then what's my imaginary part? Well, I times cosine theta sine psi plus sine theta sine. Whoops, I missed one here. I have a typo. Let's see, when I was distributing this, I have cosine theta times cosine psi. I got that. Cosine theta times sine psi. Okay, I got that one right. Then I have I sine theta times cosine psi. There we go. So that should be cosine psi. there we go. And what I was looking for, do you remember this? Cosine sine plus sine cosine. That is actually the sum of angles identity for sine. So that's sine of theta plus psi. So what do I end up with? I end up with RS times cosine of the sum of angles plus I sine of the sum of angles. And the shorthand for that, of course, is RS CIS theta plus psi.